All right, so this is going to be just kind of an overview of how I set up the virtual FlashBlade simulator to get deployed into Azure, into an Azure subscription that I have set up just for PureStorage. The intent of this right now is basically to enable a third-party partner to do some development work for Pure, and they need the APIs for the FlashBlade to do this. So the idea is that we can quickly and easily deploy a virtual simulator here in Azure and give just them access to the API endpoints and enable development. It is immutable, so anytime we redeploy, it'll just completely reinstall everything, and then we can customize some of the FlashBlade configuration as needed as part of the deployment script. So anyway, let me get started here. Basically what I've done is I have an Azure subscription. I've created a storage account in Azure. This storage account is basically what's housing the distribution of the IROS Docker image, as well, actually the whole deployment that's been used in labs and whatnot. So if we look at this, I can come into these containers, called it distro. Okay, so I have the fb-307.tar. Really, as upgrades come or updates to this, I can just replace this file and then it'll automatically pick it up. But this is downloaded through what's called a SAS token. So it's a long URI string basically that includes an authentication token. So I'll protect this. People can't actually get to these and download them without having the large SAS token. So I'm thinking this is pretty secured. The setup, this is actually the setup script. I'm no longer using this, as a matter of fact. I'll probably just delete that. All right, so I have the stage script here as well. And so what's going to happen is I'm building out this environment in Terraform. And I'm providing, some basic information. I am building out a VM, an Ubuntu VM, providing this password for now. I think as we move forward with this, we might do a certificate key for authentication versus using a password, or we can just randomize this, because really there's no need to get in to the console, as you'll see here once we get going. So in Terraform, I'm basically building out all of the Azure artifacts needed for this deployment. So that includes a virtual network. It's going to have, a resource group that contains a virtual network. It'll have a network security group. Think of that as a software-defined firewall. I'm only allowing HTTP and HTTPS into this environment. Then I have the subnet defined, which is a local, private subnet. Then I'm doing a public IP address. So this is the actual public IP endpoint that you would hit to get to the APIs and the Purity UI. And then doing the network interface, giving it a static IP. So this system will always have this IP internally when it's deployed. And then doing some associations for the network security group to the actual NIC. And then here's where I'm building out the VM. So I chose this size. We can really put any size we want in here, but this has 4 processors, and I think it's 32 gig of RAM, I believe. So, we can play with this as we need, but so far this is working. All right, so here's the operating system definition when it deploys it. It's deploying out Ubuntu 16.04. It's naming it this, putting the username and password I provided. Here's where if we want to use key-based authentication, I would actually set this to true and then pass in the key, the public key that I had created. Let's see, so here's where it gets interesting. So I'm doing, trying to use all Azure native capabilities. So I'm doing a VM custom extension, and what happens there is this is a mechanism to do kind of like post-provisioning when you build out Azure VMs. So with Linux, it'll do a cloud init. With Windows, it builds basically a base 64 encoded script of whatever you want to put in as the commands to execute, and then it pushes that as a file and executes it. Probably more information than anyone needs right now, but here's where everything gets kicked off. So once the VM's built, I'm creating this custom extension and executing it. And what the custom extension is going to be is it's going to first download that staging script over here that you see called stage. Okay, this is basically a bash script. And here is the SAS token, or what they call a SAS URL, and it includes authentication key for read access to download that directly from the VM to the OS. Then once it's downloaded, it's going to execute the command. So it'll do the .stage and kick off the build of basically the Docker environment and all the settings that we need to get this going. So then last thing I do is I spit out to Terraform the public IP address right here so that we know what the endpoint's going to be and we can get it provisioned. So what I'm going to do is kick this off, and then I'm going to talk a little bit as we go through this. So to execute Terraform, after you've initialized and done some of that, which I've already done, you can just do a Terraform apply. I throw the auto approve switch in so it doesn't prompt me to type yes. So go ahead and hit that. At this point, it's going to run through some checks. Then it's going to connect to Azure and actually start building everything out. And so we'll give it a sec and watch this, and I'll probably end up fast forwarding through some of this just because this is about a 12 to 15 minute process overall. All right, so now it's creating the virtual machine. If we refresh here, we're going to see we have a resource group. And in this resource group, nothing yet, but it's building. So as it builds the VM, things will start appearing. Then it'll associate the networking components and fire off our scripts and all that fun stuff. All right, so one thing worth noting, when I built this, actually let's take a look at the staging script. Let me open this up in code. Here's the stage script. So basically when it downloads this script and executes it, what it's going to do is it's going to, again, curl another file from our blob store, our Azure blob store, and then inline untar it right here, extract it. And this is that fb-307.tar file, which is the distribution of all the FlashBlade simulator files. All right, so once it does that, it's going to jump in, it's going to move everything inside the extracted FB folder to the home IR folder, CD into that folder, and then execute the setup script. Okay, the setup script's going to run, and let me show you that one. I haven't modified this at all, so this is the base setup script that runs, today. And so it's going to go through, it's going to extract some of the Docker information. It's going to then, install Docker, set some configs, and then it's going to basically load those Docker images in and spin them up. Okay. So once that's done, the next thing I do is I'm using RINETD, and Scott Howard turned me onto this. And basically what this service does is it enables a really lightweight port forwarding, or even it'll do network address translation or whatever, but I'm using just simple port forwarding like you would on your home router, right? And what I'm doing with that is I'm coming in and writing a config file for it to take any traffic coming to my VM's IP that I configured in Terraform earlier on port 80 and redirecting it into the bridged network IP that OVS sets up for the Docker container running, I I guess it's called SUS1 or something like that. I still need to read a little more about what all those images are doing. But basically redirecting or port forwarding traffic from my VM NIC to the Docker container IP address for VIRO. Okay, on port 80. Does the same thing for 443. So this is how I'm getting access to Purity without really having to expose or change any routing rules or anything like that. Okay, so I load that, and then I basically, restart the service to seed that configuration. Then here is where I'm creating an entry in the config-fb so that it will always set up an API token for Pure User. And what's cool is it'll actually kick this out. So when I go into my extension results in Azure, after this deployment's done, I'll actually see this in some of the output, and I can grab that token to provide to the developers that are using this, right? And then finally, I jump in and I run the start command to go ahead and start up the environment. And, the notes in the setup and the README talk about having to reboot. I think all I've noticed is if I just run this start and give it about 5 minutes, everything comes up, and you guys will see that. So that's it in a nutshell. I'm going to go ahead and minimize this, and I think what I'm going to do, let's see how we're doing. Yeah, we're building out everything. What I'm going to do is fast forward a little bit. Okay, so I did fast forward a bit. You can see it took about, I guess, around 7 minutes total to deploy this. And so now everything looks good, and here's the public IP address that we'll be going to access the environment. So just to show you some of the output, if I go into the Azure environment, here's the resource group it created, and here's all the artifacts associated to this deployment. So if I go into, let's say, the pip, okay, the pip is the public IP. Here's that IP address I have that I can access from anywhere. Here is the network security group. You'll see that my 2 rules have been added to only allow 443 and 80. So if I try to SSH to this box on that pip, it's going to time out, right? Because 22 is not allowed, and this is part of the security mechanism that I'm trying to build in place here. All right, so if we might need to give it a few minutes to fully spin up, but we'll give it a shot real quick. If we go to that IP address, okay, it auto redirected to HTTPS. This is part of the Purity configs, I believe. But we'll go ahead and jump in, and let's see if it lets us log in. Awesome. So I would say within 10 minutes, we fully deployed this environment by typing a single command. I think this is going to make it much easier to spin up these environments, especially for the use case that we have here with third-party developers needing access to the APIs. Now, worth mentioning is anytime I rebuild this, or even if I were to run a reset on this, it's going to completely start from scratch. So any configuration settings or any buckets or file systems or anything I build will be gone. So, what we can do is look at adding another script to execute against the VM as an, let me see, where am I? As an extension in here, and we could just add the piece of adding additional parameters to the config-fb file, kind of like what we did in the stage right here, right? So if we want to do more than just the API token, we could create any networks, we could create buckets or whatever just for the use case. All right, so I was going to also show you, here's the extension, okay, from the VM. If I go into this, I can look in this output, and I'm going to be able to find this particular command where it created that API token. And so this is what I would provide to the customer that was going to do some API development against the environment. That's the API token that they would use to hit the login API endpoint and create that XAuth token for authentication. And that's all documented in the API configuration. So that's it for now. If I want to tear down the environment, I can just simply run a destroy from Terraform and it'll completely deprovision everything. Another thing worth noting is the customer or anybody using this only will have access to the URL. Okay, they can only get into this. They can't get into the CLI or anything the way I have it set up. I could enable that if I wanted to. I can talk about that, but right now it is pretty secured in the fact that they can only hit the web URL and the APIs. Access to the Azure subscription itself is fully controlled by Azure AD and some of the access control through IAM that I have set up. At this point, I'm the only one that has rights, but as use cases come about, I could pretty easily create groups and maybe resource groups or something that people can work inside of if we want to enable this for other people. All right, that's it. Thank you.